Welcome to Module 5, Lesson 1, Percent Increase and Decrease. After today's lesson, we should be able to use proportional relationships to solve multi-step percent problems. In this case, we're focusing on using them to work with percent change, in this case, percent increase and decrease. All right, so we are going to jump right into it. We talked a little bit in the vocabulary about percent increase and decrease, and we're going to start off with percent increase. So we have Amber who got a raise, and her hourly wage increased from $8 to $9.50. So it's important to note that she went from $8 to $9.50, and it is important that it increased, and we want to know what is the percent increase. All right, so to do this, when we're trying to find the amount of change, or when we're trying to find the percent increase, first we have to find the amount of change. So to do that, we have to take the larger value, which was the $9.50, and we're going to subtract the smaller value. So we're going to take that $9.50 and subtract the $8. And when you do that, we end up with $1.50. So the change in her wage was $1.50, and it was an increase in $1.50. So we know that her wage went up $1.50. So we know that it's going to be a percent increase. So then now what we do to find that percent change, we're going to take the amount of change and we're going to divide it by her original amount. Okay, and after we do that division, we know it's going to give us a decimal because we're going to have that $1.50, okay, and it's going to be divided by 8. So we have a smaller number divided by a larger number, and when we have a smaller number divided by a larger number, we know we get a decimal. And when we get that decimal, we're going to get 0 and 1,875 ten thousandths. So when we divide, we get that decimal, and then we're going to take that decimal and we're going to convert it to a percentage. Now, to convert it to a percentage, we multiply it by 100. And when we multiply it by 100, we know that that means that we just swing that decimal 2 places to the right. So 2 places to the right, which means that it would be 18 and 75/100%. But since in this case it wants it to the nearest percent, it's going to be 19%. So here I'm going to actually clean this up a little bit for you. This would be 18 and 75/100%, which then rounded would be 19%. That's where I want you to not get confused. So it would be 18 and 75/100, but then because it's to the nearest percent, we would round it to 19. So again, you find the change and then you divide that change by the original. This process is always the same. Find the change, divide it by the original, take that answer and turn it to a percent. Okay, so what does a 100% increase mean? Well, if it's a 100% increase, that tells you that the amount of change is equal to the original amount. So that means if I started with, let's say that she had 100% change in her wages, that means she went from $8. So for that to have been the case, it had to have gone from $8 to $16. So mathematically, it would have been 16 minus 8, which would have then given us 8. And then 8 divided by 8 would give us 1. And then 1, if you move that decimal twice to the right, when you change that, would be equal to 100%. Okay, so a 100% change means that essentially you're doubling whatever you have. So if she had a 100% increase, that means that she went from $8 an hour to $16 an hour. Or, if you live 5 miles away from school, you now live 10 miles away from school. All right, so now it's your turn. So I want you to take your time, do your ride. Remember, it's change over original, change, or I shouldn't say change over original converted to a percent. And as always, when you come back, we'll check your answer. All right, so you should have found that you were going to take your 64 minus 52. It's always greater minus smaller. So your greater value minus your lesser value. You should have found that you had 12 over 52, which gave you this nice decimal here. And we wanted to get the nearest percent, which was 23%. So 64 minus 52 is 12 divided by 52. Divided, and that gave you 23%. All right, so here we have David, who moved from a house that was 89 miles away from a workplace to a house that was 51 miles away from his workplace. What is the percent decrease? So percent decrease in the distance from his workplace. So what is the percent decrease in the distance from his home to his workplace? Well, it's important to note that he went from being 89 miles away to 51 miles away. So he got closer. So in this case, it's a decrease because he went from being further away from work to closer to work. All right. Again, though, the process is exactly the same. It's the greater value minus the smaller value. All right. So in this case, we have the 89 miles minus 51. And when you do 89 minus 51, you come up with 38. Okay, so then after you come up with the 38, then what you're going to do is, again, you take the amount of change, which in this case was 38, and you divide it by the original. He originally was 38 miles away from work. He originally was 89 miles away from work. When you divide that, you get this nice long decimal here. I'm not even gonna, try. Well, we could go ahead and try to. So 426,966 millionths. And again, we want to go to the nearest percent. So since we're going to the nearest percent, that tells me that I am going to, yes, move that decimal 2 places to the right, which puts it between the 42, the 42 and the 6. Okay, so if I put it between the 42 and the 6, so 42, and then I'm going to stop it just at the 6. The 6 tells the 2 to round up, so that would be 43%. So in this case, the percent decrease, so David's percent decrease in distance from home to work was 43%. Okay, so David considered moving even closer to his workplace, and he claims that if he had done so, the percent of decrease would have been more than 100%. Is this correct? And explain our reasoning. So we talked about this. In order for you to have 100%, you essentially have to double, your original. So he would have had to have gone from being 89 miles away to being, now in this case, since it was a decrease, he couldn't have gone from not double, he would have had to have backtracked. So instead of going from 89 miles away to doubling that, he would want to get to 0. So in this case, he's not correct. To have a 100% decrease, he would have had to have moved to 0 miles away. So he literally would have had to have moved to work in order to have made that happen. Now, he wanted it to be more than 100%. So to be more than 100%, he would have had to have gone further away to do that. And that's not physically possible. If he would have done more than 100%, he would have then again, so he would have had to have lived at work to be 0 miles away. But then if he would have gone more than 100%, he would have started going away from work again. So again, if he was 89 miles away and then got to work and was now at 0, Now he's kept going this way. Now he's again getting away from work, which is now defeating the purpose. Now that doesn't work. He can't make it. Now he's starting to go away from work again. He's starting to increase his distance away from work again. So that doesn't work here. All right, so now you have 2 chances to practice here. And what I'd like you to do is I'd like you to go ahead and try one, and then you can come back and check, and then come back and check the other if you'd like. You have students in a chess club, and it just decreased from 18 to 12. And then you have Officer Brimberry, who wrote 16 traffic tickets, and then only 10. If you want to try one and then come back and check your answer and then try the other, you can do so. Otherwise, you can try both and then come back and check your answer. All right, so for the first one, you should have gotten a decrease of 33%. You had 18 minus 12, the greater value minus the lesser value. It's always greater minus lesser, okay? Don't worry about, because it's just the percent change. We're not worried about the original minus whatever. We're just worried about the percent change. So it doesn't matter that it started with 18 and then went to 12. We're always doing the larger value minus the smaller. And then we get 6 over 18. And if you divide that, you get 30, or the 3 repeating, and that's 33%. Again, here it's the larger of 16 minus 10 is 6 over 16, which gives you 375 thousandths, which is 37.5%. Here it doesn't ask you to round to the nearest percent, so you leave that 0.5% here. All right, example number 3. Now we are actually going to find the percent change. So instead of being given the percent change and finding instead of finding the percent change, we're going to be given the percent change and we are going to find the new amount. So in this case, we have a grizzly bear population, and it was about 270 in 1970. And in the next 35 years, it increased about 115%. Now notice 35 years means nothing to me, and neither does 1970. But the population does matter, and the fact that it grew 115% also matters. I want to know, okay, what is the population in 2005? So I need to find the amount of change. So to do that, I need to take and say, okay, well, 115%. Now I know 100% change means that this number has to have at least doubled and then some, because 100% means it got bigger by double and then another 15%. So that means it went 270 and then 15% more than that. So to do that mathematically, what we do is we take 270 and we multiply it by 115%, but as a decimal. Now remember, that means that we take the decimal, which is behind the 5, and move it twice to the left. So this becomes 1 15/100. Okay, and when we do that, we get 310 1/2, but you can't have half of a grizzly bear, so we round that to 311. So now to find the new amount, we take the old amount of 270 and we add the 311 from the increase to find that there are 581 grizzly bears. So the grizzly bear population in 2005 is now 581 grizzly bears. So again, the process becomes convert the percent to a decimal, multiply the decimal by the original amount, okay, and that's your change. That answer is your change. Take your change, add it to your original. Now you're adding it to your original if it's a percent increase. If it's a percent decrease, then we would obviously have to subtract it from our original. Why will the percent of change always be represented as a positive number? Well, in this case, we've been talking about this a little bit, and I mentioned to you that since it's always the greater value minus the lesser value, it's always going to make it positive because you always have your bigger minus smaller, which means your value is always going to be positive. So your percent change is always going to be positive. All right. And then looking at the next question, if an amount of $100 in a savings account increases by 10% and then increases by another 10% after that, is that the same thing as increasing by 20%? Well, the answer here would be no. If it increases by 10%, that would be equal to 110%. Or I'm sorry, it would be equal to 110. Then what would happen is it would be another 10% on top of, so it would be 10% of 110, which would be 121. If it did a 20% flat, that would be 20% of 100, which is just 20, so it would just be 120. Okay, so this took 10% of 100, which is 10, and then added that to, so it said 10%, so that gave you the 110, and then it took 10% of the 110, and that gave you the 121. 20% would have just come from the 100, and that would have been 20, and that would have just given you the 120. Okay, so because of the fact that this got bigger right here, this allowed 10% to get bigger because you're taking 10% of a larger number, so 10% gets bigger. Okay, so percentages get bigger as your number gets bigger. So 10% of 10 is going to be small, whereas 10% of 100 is going to be larger because 100 is bigger than 10. All right, so you have two opportunities here. You're going to find the 10% increase of a $499 TV and a 30% decrease of a $499 TV. And you're not going to have to do any rounding. You're going to go ahead and keep your change. And you're going to go ahead and you're not going to have to round. Just go ahead and do your ride and then come back and check your answers. All right, so you should have found that you took 10% of 499, which was $49.90. And if you added that to 499, you got $548.90. And then here you took $499, and here you had to switch it though, because you had to take $499 and you had to subtract 30% of your $499. So here you can add to the $499. You can put that at the end because you can do this in any order. Here you can't. You have to subtract from the $499. Either way, you took 30%, so you took 3/10 or 30/100 times 499, which was $149.70. And then you took $499 and subtracted that. Subtracted the $149.70, and you got $349.30. All right, so you're going to go ahead and do your guided practice. And as always, if you have any questions, please be sure to write them down or email me so we can go over them in class.